Good morning, good afternoon, or good evening, depending on where you're joining us from today, and welcome to this Agile Connect session, Build and Deployment Automation for the Lean Economy. This webcast is brought to you by the Agile Journal and is sponsored by Urban Code. I'm Patrick Egan, publisher of the Agile Journal, and I'll be your moderator today for this webcast and other webcasts in Agile Connect. Well, in a few moments, Jeffrey Frederick and Arik Minnick will join us to discuss how to develop and implement your own program for improving efficiency through build and deployment automation. But first, let me take care of a few housekeeping details. Our webcast environment is intended to be interactive, so you have the ability to ask a question at any time by using the chat box over on the right side of the screen. You'll also have the ability to chat with other viewers, and we'll answer your questions throughout the broadcast. We'll also address some questions at the end, and if we don't get to all of your questions, don't worry, we'll follow up by email at the end of the session. Also, I want to note that you can pop out the chat box so it doesn't get hidden behind the slides if you want to. It'll allow you to move it around the screen. Just use the little chat button or the pop-up button at the bottom of the screen. Also, if you want to follow along using Facebook, click on the Facebook tab on the box on the right side of the screen as well too. Also, if you'd like to share your experiences through Twitter, you can click on the Tweet tab or use the Twitter icon that you can see above the presentation window. Don't forget to use the hashtag AgileConn11 to make sure that everyone else sees your tweets. We'll be broadcasting the same tweet roll throughout all of Agile Connect and live at ADP West in Las Vegas. Also, if you want to download a copy of today's presentation or any other presentation materials, click on the links button. You'll have an option to download the presentation and click on links for other materials that the speakers mentioned during the presentation as well too. If you'd like to get a closer look at any slide, just go ahead and mouse over the presentation window. You'll see a full screen button pop up. Just click on that. It'll expand the screen to the full size of your browser window. And also, a recording of the entire live broadcast will be available within 24 hours, including the Q&A, so that you can listen to it again or recommend it to a friend. Well, let me introduce our speakers today. Jeff Frederick is an internationally recognized expert on continuous integration. He is a 19-year veteran of the software industry and has performed and managed virtually every role in the software development lifecycle. Also joining us is Arik Minnick, a lead consultant at Urban Code, where he helps customers get the most out of their build and release process with Anthill Pro. Arik has been at the forefront of continuous integration for over 6 years and has worked on all 3 generations of Urban Code's Anthill products. Well, if you guys are ready to go, Jeff and Arik, the floor is yours, and I'll let you take it.
All right, thanks a lot, Patrick. Thank you everyone for being here today. Arik and I are really excited to talk about this topic. Just a little bit about our background and why we chose this topic. For myself, as Patrick mentioned in the introduction, I'm a technical evangelist for Urban Code. I've been with Urban Code for about 2 years, but I've actually been doing Agile for quite a number of years, back before the term Agile actually existed. And that's what really got me into build automation, continuous integration, and I worked on the open source project Cruise Control. So I have actually quite a number of years both with Agile and its impact on development teams, as well as doing build and deployment automation infrastructure. And I'll let Arik introduce himself.
Thanks, Jeffrey. Arik Minnick. And really where I'm coming from is I spend a lot of my time helping people implement new build and deployment practices, get some automation in place. And I was really excited as I studied more on Lean and Agile to see how they fit together really nicely. And Lean gave us some tools for describing why things were doing so much better once we went Agile, once we automated. And so I really liked this topic.
Right, now a little bit more about the topic. In our roles with Urban Code, we end up talking a lot to build and release teams. And one thing we've noticed, and a very common theme as far as why people are talking to us, is because they're feeling an increasing amount of pressure. And I think there's a few different places the pressure comes from. I mean, the first part is just there's an overall push to do more, and certainly Agile is a huge part of that. I mean, there's been just, if your development teams are going Agile, then one of the big signals for that is a faster pace of builds and a faster pace of releases, and a need to try to keep up with deployment pressure. And I'm sure you see that as well, isn't it right, Arik?
Yeah, Agile does cause some pain for people who are downstream of the development team. So that's giving us a lot of pace. And then we're also seeing those challenges from more component-oriented architectures. And a lot of those smaller teams are driving smaller components. So whether it's a service-oriented architecture or just another component-oriented architecture, it's a good challenge. And then those teams are distributed, they're global, they're international, and that adds a lot more pressure. I think you'd agree.
Yeah, absolutely. And I think it's true is that even for teams that aren't agile, I think that the expectations for what the norm is has changed dramatically. So where people might have had said before, we're not agile, we just release like once every 18 months or 2 years. Now I very often hear, no, we're not agile, we only release like once every 9 months. So sort of the expectation of what a slow release is has been cut in half. So the release frequency is kind of doubled even on normal projects. And yeah, certainly the rise of the need to coordinate these different components and increasing use of global distribution, all putting pressure on the build and release process. And of course, this is it's still a time that we have not the best economy out there, so there's not a lot of companies saying, oh well, we're doubling the work, let's go just double our headcount. That's not something we're hearing. So from our perspective, the only real way to address this is looking to increase efficiency. Take the people you have and work to get more done. And that's one reason we like this topic, because we think there really is a solution to help do it. And that's what we're going to look at today, kind of how to get to that in three major pieces. So we're going to break up our talk into these three parts. First of all, just an introduction to lean software development and the concept of removing waste. From there, we're going to move into then taking what we've learned about lean and applying that view onto build and deployment automation. Finally, we're going to look at what happens as you kind of step back and get this broader view, which is part of the lean perspective as an end-to-end view, and look what happens when you talk about what we would call enterprise continuous integration. So that's the topics we're going to cover, and with that, we'll kind of jump into it with a description of lean software development. Lean is a topic that's, like Arik, I have a real affinity for. Like I said, I've been doing Agile for a long time, and I've seen Agile move through different sort of stages, major, we're kind of the norm for what Agile was changed. In the early days, pretty much the dominant Agile methodology was XP. We're currently in an era where I'd say the dominant Agile methodology is Scrum. And I think in the future, lean software development will actually become the dominant Agile methodology, provide the default language and the default viewpoint. So I think it's important to understand lean software development. In seeking to do that, I think the first thing to understand is that it's pretty much a very direct mapping from lean manufacturing. Lean manufacturing is there kind of in the roots of Agile. It inspired a lot of the XP practices, a lot of the other sort of Agile practices and Agile mindsets. But lean takes it a step further by being a much more direct mapping. The other thing I think that's really important about lean to understand is, and one thing that separates it from some of the other Agile methodologies, such as XP or Scrum, is this focus that it has on principles rather than practices. And what I mean by that is, if you go read about XP, you'll see there's maybe like the 13 practices of XP, and you should do all those 13. If you're doing all of them, then you are fully XP, and if you're not, then you're not. Similarly, Scrum is defined by a set of practices that you do. And if you're not following them, then you say, well, yeah, we're doing Scrum, but, the Scrum, but rather than actual Scrum. Lean's a little bit different, is that rather than trying to tell you change all your practices, adopt this externally defined set of practices, instead it says, adopt these principles and look at what you're doing through the lens of these principles. Arik, you want to expand a little bit more on that?
Yeah, and I think that's really why a lean approach can be compatible even with something like Scrum, because you can take something like Scrum and apply lean principles to it and use that to guide you as you evolve your practices, because most of the Agile approaches do allow you to evolve. I think that's all I really wanted to touch on there. It's just you can combine a typical agile practice with lean principles in kind of an and way. It's not one or the other.
Yeah, that's a great point. And certainly you can even apply those principles into a non-lean environment as well. So it gives a really good starting off point. Because you're not being asked to adopt a wholesale set of practices, what it means is you end up with a very low risk approach to improving your efficiency rather than a disruptive high risk approach. So I think these are all reasons why lean is a really good topic for people to be looking at when they're in a sort of resource constrained setting where they need to improve their efficiency in a low risk fashion. So we talked about increasing efficiency. The real focus, and you saw this is on the list of lean principles, the very first one was remove waste. And that's really the key in lean of increasing efficiency is this focus on waste. So much so that one of the key concepts or defining lists, if you will, in lean is this idea of the wastes of software development. This is also true in manufacturing as well. And then you can see here we've had a kind of a direct translation from what were listed as the 7 wastes of lean manufacturing into the 7 wastes of software development. And these lists come from the Poppendieck's book on lean software development and Agile Toolkit. We'll actually give that reference later in the end. That's where we pull this from. And you can see this pretty much, in some cases, the exact same topic, such as extra processing, extra processes. I mean, you can see this very direct translation of the lean concepts. So removing waste is really the key motivation in lean, and the key principle by which you improve your efficiency. So because of that, lean actually gives us some tools to go about identifying waste so that we can then remove it. Arik, you want to introduce these tools for us?
Yeah, there are a number of tools that lean provides. We're looking at 2. Spaghetti diagramming. In the classic spaghetti diagram, when we're looking at manufacturing, is you would lay down the floor plan of your factory, and then you would put your pencil down on there where a widget starts being processed, and then you would just keep your pencil down and you follow the whole path. And often what you would find is that the widget's kind of retracing steps, there's a lot of moving it from here to there, and you end up with a drawing of spaghetti on top of your floor plan. And the goal is to get things nice and clean where you have a lot less extra motion. We're going to show how to apply that into human processes and in the software. And then the other concept is value stream mapping, which is really just trying to show us when we look at the various tasks in a process, where we're spending time doing work and where things are just waiting. Because waiting is inefficient. And so that we really are trying to identify those work-weight ratios and things like that. So we're going to do a very simplified view of value stream mapping as we go.
Yeah, so these tools that Arik just introduced, these are the tools that we're going to use to analyze the impact of build and deployment automation. But before we get into the build and deployment automation examples, which are a little bit more complex, we just want to illustrate the use of these tools with a very simple process. This is kind of our Tory case for these. And this is the example of a sign-off process that you might have. It's just something you probably are familiar with, but you have a project manager and he needs to get sign off from the development manager, the QA manager, and operations so that this release is ready to go. And basically, he's just going to do this in a serial fashion. He's going to email first the dev manager, email the PM, he emails back, email the QA manager, he emails back, and so on. If we go and look at this process through the lens of a spaghetti diagram, what we see is this picture up here. We have the 3 managers with the project manager acting as a hub. And the flow through this always starts at the project manager and goes back to the project manager before it moves on to the next person. So pretty simple, pretty straightforward. If we then put that into a value stream map, what we see here now is we're going to start tracking the time that it takes to do this. Now assume that each of the emails are straightforward. They each only take a minute. The most of the time that was actually spent sort of waiting. Someone sends an email, then the question is, what's the time it takes to someone actually read it and decide to reply? Just for the use of for our example here, we're saying that on average it's 30 minutes before the manager actually texts their BlackBerry or something and sends a reply. And you can see here we end up with a ratio of waiting and working that's actually pretty terrible, right? It takes us 30 times as long in waiting as it does to working. So if you look at our overall value stream, for every 156 minutes, we have 6 of those minutes working and 150 waiting. So that's a terrible ratio. And we want to try to address that. So we can imagine how to do this in a simple way. We're going to just say, rather than this flower pattern where everything comes back to the PM as the hub, let's have our managers simply go on to the next manager. So the PM will ask the dev manager. When the dev manager says, yep, it's good with me, pass it on to QA. QA's done, pass it on directly off to ops. And then that's finally all the sign-offs are done. Then we go back to the PM, and voila, we've managed to go and pull out a couple of those steps, and we've gotten our process time down actually quite a bit from a relatively simple change. So that's a really simple example. You can see the tools we have now are the spaghetti diagram to identify wasted motion. We have the value stream map, which is identify extra waste and waiting. Now, there's other kinds of waste, but these are really the ones we're going to be the primary focus, because there's such an easy win for so many people. So that's our quick summary of lean software development, at least as far as we're going to be applying it today. But if we were going to go and give you an exam at the end of this, these are the 4 points we'd want you to take away that they're going to be on the final. Number 1, lean software development. Hey, it's inspired by lean manufacturing, pretty much a direct translation. 2, there's a really strong emphasis on removing waste. 3, that there is a list that identifies and categorizes the 7 wastes of lean software development. And finally, number 4, that there are these tools that lean provides for actually visualizing the waste to help you identify them. So with that, we're ready to move on to our second section, which is now applying these tools into the build and deployment arena. And we're going to start off with the sort of the common scenario we see of having the designated build person, who we will term Bob. That's right, Bob the builder. Arik, you want to explain Bob's role and how often we see him?
Sure thing. Yeah, and we see Bob a lot, although a little bit less and less these days. But basically, Bob's the build guy. He's the one who knows how to do the build. He's the one with access to the build machines, probably the one who wrote the build scripts. And pretty much he's in a service role. So you'll be in a situation where programmer like Pam will make a bunch of changes, send them to source control, and say, you know what, I want to get a build of what I just did. So email Bob, say, hey, can I get a build of this and that? Look at this tag in source control. Bob will go ahead and get that email, perform the build, and then when it's all done, email Pam back and say, your build is done, you can get it here. Hooray, life is good. And so I think this is a pattern that we see often, but it's not necessarily the most efficient way of doing things.
Yeah, it's not, but one thing, Arik, I think is worth pointing out is 2 things. One is, though it's not efficient, people have a good reason to do it, which is they say, look, we want to have a controlled build process. We don't want just any random build from developers' desktops. And so
right.
in the seeking control, people are looking to Bob as the solution. Isn't that right?
Yeah, and because Bob is good and Bob is disciplined, it's a lot easier for Bob to do things the same way every time than to have a whole group of programmers who are all going to follow the same set of procedures. It's a lot more likely that Bob does it. And hopefully that takes a lot of load off the developers, right? They don't have to worry about doing all these builds. So in the ideal case, it's a win-win.
Yeah, so I just want to say there's good motivation. And the second is there are cases where someone will say, look, we don't have a Bob, we don't do that. We don't have that inefficiency. We just make sure like our tech leads are the people who supply the build and they just do it off their desktop. Guess what? If it's your tech lead who's doing it, your tech lead is acting as Bob. Right? You may call him Ted because he's the tech lead, but he's still acting as Bob if every other programmer needs to go through them to get the build. So that's the 2 reasons. Understanding one is that people do this for good reasons, and second is that even if you don't think you're doing it, you might actually be using this pattern because you have a different person acting as a gatekeeper. It's not about the role, it's about the person who is acting in this role as the bottleneck, which I think we can see here if we kind of diagram it out, right? So this is the spaghetti diagram of the Bob the Builder pattern, and it's pretty simple. It's actually, arguably simpler than the example we had earlier with the sign-off process. Basically, if Pam wants to build, she has to go through our interface, our human interface to the build system, and when their person's done, they can say, yep, your build's ready to go. If we go at this in the value stream map, we start to see the inefficiency. This doesn't look inefficient. This looks, straightforward. And in the best case, this actually feels really pretty efficient, right? Look, I mean, if you look at the ratio, you know, Pam emails Bob, he gets right to it, he runs the build, he's working, and 15 or 20 minutes later, we have a build. Great. There's not really a lot of inefficiency. But Eric, you seem to think that there was, so why don't you explain, what goes wrong here?
Exactly. So we don't really believe that Bob's going to read his email the moment we send it to him, because he's only able to do that if he's just staring at his computer, hoping an email will come in, so that he can perform a build, because he's that bored. And in this economy, no one is that bored. And if they are, they're really working hard to pretend they're not. What's really going to happen is Bob's going to be at lunch. Bob's going to be in a meeting. Jeff, you and I have both been in the meeting when Bob's BlackBerry went and he said, yeah, going to have to do that build when we're done with this meeting. Pam did not get her build right then. She got her build when the meeting was over, when Bob got back from lunch, when all the more important builds were done first. So really, this whole idea that we can send it and it'll happen immediately just isn't true in the real world.
Yeah, and and you're just looking here in terms of the email, but obviously this happens at every step of the way, right? Every time where Bob does an action and then he needs to wait, so he's going to start a build and then he's not going to sit there staring at the console for 10 minutes. He's going to be surfing the web. He's going to go get a cup of coffee. He's going to then strike up a conversation and so on. Every single time that there's some action he needs to take, that's a potential point of interruption. And as you say, we know about these things firsthand because, a lot of times we are the interruption. We'll come and say, hey, Bob, time for the meeting we have. He goes, oh, yeah, right. I guess I'll get back to this, build when I'm done. So the fact that you would have, a very efficient process here very often doesn't become the case. It's because Bob's availability is really makes him the bottleneck. And as we say, Bob's busy. Bob's got a lot going on. That was our whole starting premise here, is that given the effects of Agile, given the effects of build complexity, given the impact of distributed build teams, there's more and more work to do for these build people. They're more and more busy, and we see that all the time. So this fantasy that you're going to have a very efficient process with Bob as the hub isn't what works out in practice.
Yeah,
so,
and you brought up a good point in that with more and more work, more and more of a bottleneck, and the time it'll take will be slower and slower. So when you need your build the most, because it's the most critical time, is when this process will be slowest.
Yeah, that's a great point. And I know we've talked to people who are doing their their system go live, and in the process, so they need to they have some things that fail in validation and staging. They need to send a bunch of emergency builds, and suddenly we have all these builds trying to go through the same bottleneck at the same time, and it makes that deployment process stretch out at the worst possible moment. So that's true. So that sort of unknown impact on waiting is what makes this so inefficient. So clearly we say, look, the solution here is we go ahead and use build automation to break the bottleneck. We're going to allow Pam to come in now and directly trigger their build, and she can self-service herself and get a build back immediately. Now, I had said before that Bob was here as a control, as to make sure that they were getting the official build and there wasn't sort of random stuff happening in developer desktop. I'll make it clear here that people might look at this and go, well, what happened to separation of duties in this case? But I think Eric will agree that the key idea is that while Pam can trigger the official build process, she can't necessarily change the official build process. Isn't that right?
Yeah, there's some magic going on here where the build machine just runs it. And that magic was configured by Bob in all likelihood. So he's responsible for setting everything up. And then, he'll just let Pam trigger it because he's never saying no to Pam. He's just saying, I'll do it later. You might as well just give her a button that she can press and the build will run. It'll be logged any parameters that she passed in or anything like that.
Yeah, and I think that's a great point. Is that people, especially if you're in the role of Bob, you might look at this picture and go, "Wait a minute, what happened? Am I fired?" And no, I think that's really the key idea. Is that there's that steps have been set up by Bob. The invisible hand of Bob is actually in this picture, enabling this. So Bob just has better things to do than act as the machine to be waiting for Pam's request. And so he's enabling this kind of system and keeping it healthy and expanding it over time. Now, so the picture doesn't look that different, but it actually can have a pretty big impact on the build value stream. First of all, we take out a couple of those steps where we have the whole email back and forth process. And if you look at the numbers, though, if you compare to the best case, it doesn't seem that different, right? You look at it before it was 16 minutes of working, now we're seeing it's 3, and the waiting before was 2, now it's 1. The real win here, though, isn't that we've reduced the total amount of time, but that we've reduced the uncertainty, right? We now improve the predictability. I mean, I think you have a good point, Arik, about people who are in, Six Sigma kind of organizations, or some sort of CMMI process improvement. Having that predictability can be pretty important, isn't it, right?
Yeah, to just know that when I press this button, in 15 minutes, I'm going to have a build back. That's what Pam has now. And to some extent, if she had that, even if it took on average as long as it took Bob to do it, even if it took an hour, that would be okay. The really good news is that now we've made the normal be the same as the previous best case, which is fantastic. We are actually faster, particularly when we're looking at wait time, but just the knowledge is really good. Pam knows she can grab a coffee when she comes back, Bill to be there, and she can go do that. As opposed to, I might have it done in 10 minutes, and I might have it done later this afternoon. So just a huge improvement.
Yeah, the psychological wins, like you say, of the reliability is a real confidence builder for the team. It actually changes their behavior. And that's what I've seen time and again. You get people say things like, oh, just a second, I'm waiting for the build to finish, and then I'll go to lunch, as opposed to, well, I guess I'll go to lunch now because who knows when I'm actually going to get the response back. And I will give you a real world example of people who've gone through this transition from a Bob-driven system to a automated system. Arik, I'll let you talk to this because you're pretty familiar with this client.
Sure, we had a team of basically 4 Bobs who were doing the builds and some deployments, mostly the builds for 16 different projects. But then they were told, we're doing some consolidation. You guys are going to have 10 times as much work to do. And by the way, you don't get to hire anyone, so figure it out. So that was a little bit challenging. So they introduced this automation so there could be some self-service, or best, they could just press the button and it would happen. And they were able to handle all those projects. They were able to do 10 times as much work. And their big fear was that they weren't going to be as responsive. But they were actually able to be more responsive. The average cycle time went from 90 minutes to 20 minutes. That was fantastic. And they just are getting more and more work. The business loves them. They're getting more responsibility. They have higher profile. They're given 450 projects. I think the latest numbers are higher than that now. It's very, very doable.
Yeah, and I think that's a great example of someone who's taking adversity and turning it into a real opportunity to change the game. If you still, not just like you're going to do a little bit more work, but you need 10 times as much work that you're going to be servicing. The idea of going and hiring, growing to 40 people, clearly not that attractive. And by moving automation, these people, again, were not gone. These are suddenly just much more valuable, much more leveraged people. And I got to think that not only are they providing better service, but they'll probably enjoy their job more as well, because they're not sitting there acting as robots, trying to run builds manually anymore. They get to actually do, fun stuff building the system and, feel like heroes for bringing in all these projects and providing service to them. So I love this scenario of taking what was a real challenging environment and scenario and turning it around into a real win for the company and for themselves personally. So that's kind of the build story. We're going to go ahead and extend that out now out into the deployment scenario. And keeping with our creative naming stories, of course, we're going to do deployment. It's going to be Dan doing it, and this should be deja vu. Do you want to do the very quick run through this, Arik?
Yeah, pretty much same story. Pam, got her build back. Now wants to deploy it into a test environment. She's going to ask Dan to do it. Dan will do it eventually. Email her back when it's done. So pretty much the same story, and I think we'll see a very similar diagram here as well.
Yeah. So, diagram, real simple. Again, we have a person acting as an interface to the machines. Um, but, so we expect, of course, when we go look at the value stream map, we're going to see something pretty similar. The big question is the same problem with any human gated process. When are they going to be available to actually service my request? And the reality is, everyone's busy. We just don't find that many people out there these days with tons of time. Sure, come in, meet with us anytime because we have nothing to be doing. Those people just aren't around much anymore. So we're going to make the same kind of change here. We're going to go ahead and remove the human element. Again, not entirely. They're just not in the picture, but that invisible hand of Dan is still there, making sure the deployment automation is running smoothly, setting up more deployment automation, servicing more teams, growing from 16 teams to 400. That's what's going on here. And again, the consistency is the real win. Although, sometimes that removing those bottlenecks can be a systemic win, especially in cases like this one. I'm going to go ahead and handle this story, Arik, because this is one of my favorites. It absolutely is. I love this story. We had this company we worked with. They had an offshore testing team. The offshore testing team were contractors, and so they were not allowed to log into the systems in the test environment directly. They couldn't log in and actually do the deployments. And as a result, they had to go and send email to the onshore team saying, hey, please deploy the new build whenever they were ready to take a new one. Obvious problem for anyone who's worked with offshore. We're talking about a minimum 24-hour turnaround here. So the average turnaround time was about 20 hours. That was kind of the norm for them. Whenever they asked for a new build, is that 20 hours later they hoped to have one. Sometimes it was worse than this, right? Sometimes the build and the deployment didn't work out for some reason, either because of bugs in the build or because there was a deployment mistake. And then suddenly you're talking about 2 days to get a new build. So that has a huge impact on the productivity of those testers. What they're able to do, though, is just go and say, great, we're going to have deployment automation so that these people can push a button when they need a new build. So rather than waiting for someone to come in, they can do it manually. They can just go, trigger it and make their request. And suddenly they went from 20 hours to 1 hour, right? So savings of let's say 19 hours for the entire offshore team, right? So if you're talking about 10 people, you're talking about 190 man hours saved. Fantastic savings just from having the ability to push a button to get that done. So I love that story. Because it's something I think a lot of people can benefit from. And that's such a clear case where you see the impact of delays. Anything else you want to add to that, Arik, or ready to move on?
Yeah, the only thing I'd add to the deployment narrative here is that you're going to do this not just to one test environment. Any inefficiency you have in your deployment process is going to be repeated through each testing environment you have. And I think we've seen that the average is 4 or 5 different environments that a particular build will go through on its way out to release.
Oh, that's a great point. Yeah, that it's not just like the one test environment, but there's performance testing and there's staging and there's functional tests and system tests and all. We have some customers that have over 10 environments that they deploy to, right?
Absolutely. Yeah.
So yeah, that's a great point. That these savings are not just a one-time savings, but you're saving it in every step along the way. So we've kind of done now. I think we've slowly set the baseline. People should understand now the concept of the lean, focus on eliminating waste. We've now applied that to build and deploy automation. I think it's really the straightforward case. I think everyone could go and actually start with those scenarios. But let's go ahead and move and say, look, let's get that sort of whole end-to-end perspective and look at this from an enterprise continuous integration or enterprise CI perspective. I think to start out, though, let's clarify what we mean by enterprise continuous integration. The term continuous integration actually goes back to extreme programming. When their continuous integration was not actually had nothing to do with automation, it was really a manual process. They were trying to avoid integration hell. So the question was, how often do we commit our code? Are we all working on the same code base all the time, or are we diverging, and have to integrate later and feel that pain? So that's really where things started, and people realized that if they're checking in all the time, it was nice to have this build triggered automatically. So this idea of automated continuous integration came about, which is the idea is that rather than even having someone have a button to trigger the build automation, but they could actually just have the system run it automatically and will give feedback to the team if anything happens. So you have these two practices of committing frequently and getting rapid feedback, both with the term CI. Most of the times now when people talk about continuous integration, they usually are talking about a CI system, and they're talking about the sort of automated feedback. And it's really from that perspective we're saying, take that automated continuous integration approach, but extend it beyond just the build, beyond just unit tests, beyond feedback just to developers, out into the full life cycle. And to kind of clarify this and expand on this idea, Arik and I wrote a white paper. You can get it from the download section or from our website on an enterprise CI maturity model. And if you could squint really, really close here at these words that are on the screen, or you can just go get the white paper and the associated wall chart. And in this, we kind of lay out both where we think the average person in the industry is, where the average team in the industry is, and also we identified targets that you might want to shoot for along the way. And one of those targets is actually in deployment, and what we think people should be aiming for is continuous deployment, which brings together two pieces, the continuous integration build as well as automatic deployment to the first test environment. Do you want to kind of explain this and the terminology and where this fits in the world of continuous deployment?
Sure. So our scenario here is the developer commits a change that triggers a build. When the build's done, it's moved off to some sort of authoritative storage. And from there, deployment is automatically run into the test environment. When all that's done, we let the programmer know, the developer know what's going on. The term continuous deployment itself is a pretty loaded term. Some people are using this to discuss a series of tests and deployments that carry all the way out through production just from a developer commit. And there's some variants on that, like continuous delivery, which go almost all that way. For our purposes here, we're just looking at that first test environment, but these same concepts drive all the way out towards production. And some of those are really driven by lean. Teams that have tried to get very, very lean don't want to have good code changes sitting on the shelf, not delivered to customers. They're trying to figure out how to get that to production as quickly as possible.
Right. This idea of continuous deployment, and you mentioned going to the first test environment. What would you say to someone who says, that sounds great, but I'm a tester. I don't want my test environment changing out from underneath me. How would you address that concern in a continuous deployment environment?
If the test cycle, is interrupted by a deployment, then you don't want to be doing that all the time. And so you might be doing, once or twice a day automated deployment like this on some sort of a schedule. Or that first test environment could belong to the developers, just so that they can see their software running and they can validate that it's doing what they think it should be doing before it goes off to the testers.
Yeah, and I really like that pattern that you just described of you have a test environment that's not the same as the QA environment. So, if QA people are in a long-running test cycle, you don't want to interrupt them. We certainly agree with that. But the idea of, look, you can have this deployed automatically somewhere else so that anyone can go see the current state of the build, the current state of what's checked in at any given point in time, that's hugely valuable. And, rather than actually waiting for the test environment to be updated, with the QA environment to be updated, that anyone can go and see, like, yep, this is the current build. And you might even use that to say, well, let's go ahead and see if that's something we're ready to take into our official test environment. But you have that ability to get feedback much faster without waiting for QA. So I like that. And we know that even just this simple pattern can actually, bring huge evidence. And so, we're going to talk through this customer scenario of continuous deployment, Arik?
Yeah, absolutely. So these guys really couldn't test their software without getting it in some sort of an environment. And so the challenge was, how do we get it out into that first test environment quickly? They had kind of the Bob the Builder, they had Dan the Deployer, they had those people who were frustrated by the inconsistency of time, Six Sigma shop. But they knew that on average it took about 2 hours to get all those emails done. With this sort of thing in place where they commit a change, and it's just sent out to the first test environment as quickly as possible. They're able to drop that cycle time to 7 minutes. And it was really 6 minutes to 8 minutes, as opposed to 20 minutes to 4 hours. Again, that consistency in addition to speed was really nice for these guys.
Yep. So huge wins there, and these are people who are real happy to no longer be in the Bob and Dan button pusher. If we mentioned before the 7 ways of software development, we're going to run through a scenario here of kind of now if we have this full end-to-end enterprise CI system, putting all the pieces together, and we're going to say how we address 5 of the 7 pieces of 7 ways of software development. So this is the scenario we're going to look at, and basically what we have here is our programmer Pam is going to commit a new feature. That feature needs to be built, it needs to be deployed, it needs to be tested to verify that it's working, but the tester is going to find a defect, and we're going to go back to that cycle again. So let's start by looking at the spaghetti diagram. Arik, you want to step us through each of these step by step?
Yeah, it's a lot of fun. It's a lot of fun to put together the example. This is where we actually see spaghetti take its meaning. We're able to look at this and just go, ugh, it doesn't feel good. As opposed to some of those other ones, it doesn't look so bad. When you bring in this cycle where we go through it twice, this really doesn't look good. And I think you can spot where there's some problems. And we can look at this in some of our other tooling to really break down what we don't like.
Yeah, and I think you especially appreciate it, Arik, because you did all the heavy Visio work here. So you did a lot of work to make this look as simple as possible, and still looks like a pile of spaghetti. If we go and apply this now to the value stream map, and we bring in this sort of the normal kind of things, people who do maybe a nightly build, maybe they only deploy it to their QA environment twice a week. That's pretty typical. People take maybe 2 builds a week out to QA. Then you're going to have the time spent actually finding the bug, reporting it. It takes a while for it to be triaged, actually back to the developer, and then it gets fixed. We're talking about something that takes about, on average, about 8.5 days for a shop that's doing all the stuff manually to actually be able to run through the cycle. And I know I've talked about this with lots and lots of people, and I get a lot of confirmation that people go, yeah, that's about right. That's about how long it would take us to run through this cycle. So what we want to do now is show you what it can look like if we go and take out, address with different parts of automation. First off, if we're doing that continuous deployment, then both times that we build and deploy, we're going to be attacking those waiting elements. If we have automated testing, if we have unit tests, if we have static analysis, if we have automated functional tests and so on that can find the defect, then guess what? We can go and automatically find the defect and let Pam know right away without that delay. And if we can then let that Pam know right away, right after she actually made her change, we don't have to go through the whole triage cycle, right? Because we don't say, well, where did this bug come from? We say, well, look, Pam made a change and she triggered this test failure. Hey, go fix it. So that's going to be addressed. So we're really identifying each of these different elements that with these long delays and attacking them through automation. It'll actually take Pam less time to fix it because she's still doing that work. She remembers the changes she just made as opposed to finding out 3 or 4 days later. So this is our revised view of the world. We don't have a Bob and Dan anymore. We're going through the cycle. We find the defect. We only have to go through and test it once. I'm guessing this was a little bit more fun to draw. Isn't that right, Arik?
It was. And I like to point out that all that messiness over on the right, that's all in the automation. So that's the stuff that was configured once by Bob and Dan, and now just happens the same way every time. The simple stuff is over with the people.
Yeah, that's a great point. People look at this and go, wow, there's still that complexity. And we go, yeah, but it's machines doing it, not people. So you don't have the delays, you don't have the possibilities for errors. And now you know what Bob and Dan are doing when they're not in this picture. They can actually make this kind of system work and actually expand it, make it, put more features in it. So over time, it gets better and better. As nice as this picture is, the real impact I think you see is in the value stream map. Huge reduction in time here. Right, because we're not waiting around for things to be deployed. We're not waiting around for getting the feedback on the bug. We have this huge impact where we instead of taking 8.5 days to go through the cycle, we're talking about making that full cycle in about a day. And most of that you'll see is actually waiting for Tom, the tester, because we're assuming that you didn't, wire this in directly into the manual test environment. So Tom's still going to wait for his, half a day to go by for him to get the new build and then actually go through and get around to actually doing his work cycle. That's where actually most of the time is spent. If you can do things to make that more efficient, you'll drop down this time anymore. I think when we look at what where the savings come from, we can kind of look at it in going back to that list of wastes. Arik, you want to kind of walk us through how we've addressed the different pieces of the 7 wastes of software development?
Sure. So we haven't touched the partially done work or the extra features. That's still on the team. We've really, limited the extra processes. There's probably not as big of a triage meeting. There isn't a lot of discussion. We know who is to blame. Because Pam is notified so quickly of the problem, trying to get back and remembering what she was working on lowers the expense of task switching. Obviously, kind of that weighting and the motion, that's what we saw with our spaghetti diagrams and the value stream. And then on the defect side, because that first bug was caught by the automated test, Tom wasn't doing nothing that time. He was testing something else. He's finding some other problem. And so we are going to see higher quality result.
And I want to expand on the impact of defects a bit more, right? And I'm going to use an example developed by Michael Bolton, not the singer, but the Agile testing consultant. He has this great example, and he says, imagine that testing a feature takes 2 minutes, right? But that when you find a bug, it takes 10 minutes to go investigate and report it because you need to do all the setup and capturing all the details. So he says, in a 90-minute session, you can run through 45 features, but only if you don't find any defects, right? And so if you start finding defects, suddenly you have this big impact in your scheduled testing session. And so you kind of say, and this is just for the tester to get through their tests, right? So if you find 9 bugs, if there's 1 bug in every 5 features, then you're actually doubling the testing time to get through that. So anything you can do to pull these defects out and catch them earlier is going to have a huge impact. And that's only just looking at the impact on the tester. There's also the impact on the engineering time to investigate, the time to retest, and of course then you have those bugs that are hidden behind other bugs, the ones that you find later because you couldn't get to them because the bugs are in the way. So there's all kinds of other costs, but even these have a big impact. Putting them all together, you end up with the overall impact. And this is from an IEEE survey saying that if you do builds at least daily and you run integration tests so you can find defects sooner, you end up with a huge impact on both productivity, you're much more productive, and you end up with a much better defect rate, so you're much higher quality. So, I think that really shows you the impact of that. With that, we've kind of gone through our different topics. One thing we want to say is people always ask us, hey, I know you have these tools. Can we use them to do this? I don't know if we're going to have time for many questions, but I wanted to at least get this one out because people always ask this question. We essentially have 2 products. We have Antel Pro, which will automate the end-to-end cycle, including all the build and unit testing, static analysis, that sort of development automation infrastructure. And we also have Urban Deploy, which will help you if you just want to deploy in a reliably consistent fashion across all your environments. So I just want to get out there. And we also mentioned the different resources. One book we mentioned was the Poppendieck's Lean Software Development and Agile Toolkit. There's resources on our website and also available here to download on the online site. Check out our blog. And we kept talking about bottlenecks. And if you want to learn more about the importance of bottlenecks in software development, go read The Goal, which is about lean manufacturing, but you'll see how it pretty much directly relates to bottlenecks in software development as well. And with that, if anyone has any questions we don't get to today, feel free to email Arik and I. We love talking about this stuff. And with that, we'll open up if we have time for maybe one question.
I think we got time for a quick one. Great presentation, as usual, Jeff and Arik. And again, if you have any questions, go ahead and use that Ask a Question box on the right side of the screen, and we're going to jump over real quickly to the next session in Agile Connect. And I know that both Jeffrey and Arik will stay online in the chat session for a little while, so feel free to keep chatting away. But here's a big question for you. Talking about Bob and Dan, is there any value in having a combined Bob and Dan, someone who handles both build and deployment and acts as a single point of contact, someone like a configuration manager who controls what in all environments as well as what's in source control?
I know a lot of people attempt to use that pattern, but the problem is very often that the same kind of knowledge doesn't translate well across all these. You can put one person in place as a gatekeeper, but they can't really always facilitate the problem. So for example, if you're doing your J2E deployments, the person who is needs the WebSphere administration knowledge to deploy a component is not going to have necessarily the same person as the knowledge about your branching strategies in ClearCase, or the same person has knowledge of doing your, ANT scripting. So while there can be value in a single point of contact, I think it's hard to certainly combine all that knowledge in a single person, except for in some cases. So that'd be an exception, not the rule. Arik, anything you'd want to add to that?
I think the only other concern is around separation of duties, but that'll be an organization sort of concern.
Yeah.
Alrighty, well, thanks you guys. Again, great presentation, and all of the resources that both Arik and Jeff mentioned, you can find over in the links tab there. A lot of good things that you guys were talking about earlier, especially like the idea of Bob the Builder. Maybe we should replace those guys with Bill and Ted instead. But I look forward to seeing you all in our next webcast, and thanks to everyone who helped put this presentation on today. Bye-bye, everyone.